take magnesium. Okay, this is magnesium. And I'm going to take, for the next reaction, I'm going to take some hydrochloric acid. Okay, that's this, HCl. Let me write it down on the board.
Where did you get that?
HCl. You can get HCl at Home Depot, Osh. They use it in swimming pools. They use it for cleaning concrete. They use it for a lot of things, but don't ever go getting chemicals, playing with it yourself. This is very dilute. I buy it at 28%, and I dilute it down to about 5%. So this is about 10 times stronger than what's in your stomach. Your stomach has about 0.5% hydrochloric acid. You ever burp or vomit a little bit and burns your throat? Or
It's a verb.
burp? Well, you know. You ever vomit? Anybody ever vomit? Anybody ever hurl, dump their cookies?
Of course.
What do they say? What do they say? What's the
Yeah,
expression?
Oscar did. Oscar likes it very much.
So I'm going to take some hydrochloric acid. Now, feel this hydrochloric acid. Was it feel? Don't grab a hold of it.
Don't grab it.
Keep the goggles. I didn't say take the goggles off. Why did you take the goggles off? Feel it. How does it feel to you? How does it feel? Just feel the outside. Does it feel hot, cold?
Like water?
What does it feel like? Does it feel hot, cold, what?
You burn out the stool with it.
What does it feel like? Hot or cold? So, this is magnesium. Little pieces of magnesium. All right? And hydrochloric acid. Just answer. Does it feel hot, cold, medium, or what? Cool? Real cold? What? There's water on the outside. Does that feel warm? How does this feel to you?
I feel it.
Cold? How does it feel? Room temperature, cool, not much, maybe a little cool, maybe room temperature. I'm going to put in the magnesium, okay? And there's fizzing going on. Something is happening. It's fizzing. And one way you'll be able to tell is after a minute or two, it's going to start getting warmer. All right? So this is, by the way, hydrochloric acid is acting as a solvent now. It's acting as a solvent. It is dissolving. It is dissolving metal. It's dissolving the metal. I'm going to put this in here, and we see that bubbling. That bubbling means a gas is being produced. So I've got hydrochloric acid and magnesium. Those are the reactants. They are reacting. Now, this is kind of important that I get this right.
And you
I've
have
got
a leak going on.
this much oxygen, so I need twice as much hydrogen. Because I want 2 parts hydrogen and 1 part oxygen. So I'm going to measure roughly with my fingers. I'm going to put in hydrogen gas.
What's leaking?
Oh, it's at the top here. It's leaking out a little bit. It's always really messy. So once again, we're bubbling in. This is a reaction. Bubbling in hydrogen gas. And now, I'll stop when we get to the water. So I've estimated. Right there. I've got about twice as much hydrogen as oxygen in there. So we'll leave this sit here for a second. Let me finish this. Take a look. These are the reactants. What do I get? Who can tell me what I get as a product? The bubbling was what? Anyone want to guess?
Was it decomposed?
The bubbling was hydrogen gas. And what's left over? Magnesium and chlorine, right? What do they make? The chemical name for magnesium. Magnesium chloride. This is a rough idea. To be precise, we have to do this. Then we have to do this. Okay? This is called a replacement. We replace the hydrogen with magnesium, and after that happened, the hydrogen came bubbling out. So that's a replacement. This is a decomposition. This is a replacement reaction. It produced some gas, all right? And you can feel, now when you feel this, you can feel, it feels, how does it feel? It's not hot, but it's a little bit warmer, can you tell? It produced a little temperature change because the molecules start moving around faster. And you can feel, if you feel it, it's a little bit warm. It didn't get hot. It's not that noticeable. You know, you got to be paying attention. You got to be thinking about it. There's still some magnesium in there. I'm going to leave it until it all completely dissolves. As the magnesium dissolves, the acid attacks the magnesium. The magnesium weakens the acid. The magnesium actually destroys the acid. There's no acid left over here. So, you know, anybody have the idea you have a real strong acid, you pour it, it just keeps dissolving stuff? That's not true. As it dissolves stuff, the stuff it dissolves makes it weaker. Now I have a tube full of oxygen and hydrogen. Twice as much hydrogen as oxygen. Now, why don't oxygen and hydrogen make what? What common chemical? What? Water. Water. Why don't they just start making water? You got oxygen and hydrogen there by themselves. Why don't they just start making water?
Because it's
They don't
already
feel
poisoned.
like it.
What did you say?
Poison.
No, it's not a poison. That's pure hydrogen and
So
oxygen.
that's water right there.
That's not water.
Oh,
They're
I thought
not
it was
mixing. Hydrogen and oxygen are pretty high energy. The bonds between them are real weak. Hydrogen is like this, and oxygen is like this, and the bond is real weak. There's a lot of energy in those chemicals. If they make water, they make a chemical that's much more strongly bonded. So these are called high energy chemicals. H2O and O2 are high energy chemicals.